Different parts of Airbus aircraft are transported using a cargo plane called the Beluga. But just imagine, when it comes to the world's largest passenger plane, the Airbus A380, transporting its massive joint parts using any regular aircraft is simply impossible. That's because there isn't a cargo plane in existence that can fit this palace-like aircraft inside it. So how are the parts of the A380, which are manufactured all across Europe, transported to Airbus's final assembly unit? Welcome once again to a video by the Timeless Forgotten Mysteries. Airbus is a European aircraft manufacturing company that produces nearly 1,000 aircraft each year for airlines around the world. That's roughly 3 brand new aircraft every single day. To meet this demand, Airbus needs to produce 3 aircraft daily, a task that's almost unbelievable in scale. But how exactly are these aircraft made? That's a story in itself. And the parts, which are manufactured in various corners of Europe, how do they reach the city of Toulouse in France, where Airbus's main assembly unit is located? Airbus's logistics system combines sea, river, land, and air to form one of the most complex transportation networks in the world. Its aircraft parts are built in different countries across Europe and then brought together in one place to create a beautiful, massive plane. This is no ordinary operation. It's the result of decades of engineering brilliance and careful logistical planning. In the 1960s, major European countries like France, Germany, Spain, and the UK came together with a shared vision to compete with the American aircraft manufacturer Boeing. Their goal was to form an alliance capable of building large commercial planes. But the biggest challenge of this partnership was the fact that Airbus had 11 production sites scattered across Europe. Each site specialized in a specific part of the plane. For example, the tail sections are built in Hamburg, Germany. The central and nose sections are manufactured in Saint-Nazaire, France. The wings are made in Broughton, UK. And the tail sections are also built in Cadiz, Spain. Once all these parts are ready at their respective factories, the Real challenge begins, transporting football field-sized parts to Toulouse, France, where the final assembly takes place. In the beginning, when Airbus aircraft were in lower demand, they used trucks and ships to transport these parts. But this process was slow and could take months for delivery. As demand grew, waiting months became a major obstacle to the company's growth, especially when the goal was to build 3 aircraft per day. To solve this issue, Airbus came up with a brilliant solution. Inspired by the Arctic beluga whale, known for its echoing, almost melodic calls, Airbus designed a unique cargo plane in 1994 and named it the Beluga. The sole purpose of the Beluga was to transport large and heavy aircraft components. It had features that no regular cargo plane possessed. In terms of size and capacity, the Beluga is 56 meters, 184 feet, long, longer than an Olympic-sized swimming pool. It stands 17 meters, 56 feet, tall, about the height of a 7-story building. Its cargo space is so vast that 182 Suzuki Altos could fit inside. Its most unique feature is its nose section, which opens upward like a car hood, allowing for easy loading and unloading of aircraft parts. A pair of Airbus A380 wings, each 32 meters long, can fit comfortably inside the Beluga's fuselage. The cost of just one such wing pair is around 40 million euros, roughly 400 crore rupees, meaning even the slightest damage during transport can cause massive losses. This is why extreme caution is taken at every step of the loading process. Where trucks and ships would take months to deliver parts to Toulouse, the Beluga can complete the same journey in just 2 hours. Thanks to this speed, Airbus's assembly line continues to operate without delays. Following this success, Airbus launched an improved version of the Beluga in 2014, the Beluga XL, which could carry even larger and heavier components. Everything was going smoothly, until 2004, when Airbus launched the world's largest passenger aircraft, the A380. The A380's fuselage is 8.4 meters tall, and the wingspan near the fuselage reaches up to 16 meters. The problem? The Beluga XL's cargo compartment is only 7.5 meters tall. That meant neither the A380's fuselage nor its massive wings could fit inside. And here's an important detail. While fuselages can be built in sections and joined later, wings are made in one single piece. That's because wings contain fuel tanks and hydraulic lines, and they bear the most structural stress. Manufacturing them in sections would compromise structural integrity and increase the risk of fuel leaks. So, Airbus considered developing a new, even larger Beluga, the Beluga XXL, specifically to carry A380 components. But this came with major complications. They would have to redesign the aircraft from scratch, upgrade engines, and invest billions of euros. On top of that, the A380 was so massive that not all airlines could operate it, which meant its market demand was quite limited. So, for just a few aircraft, investing in a new Beluga XXL didn't make financial sense. The idea was dropped. Airbus now needed an entirely new transportation method. And this marked the beginning of a story involving land, rivers, and sea, the journey of the super convoy. Airbus developed specially designed roll-off ships to move these oversized and heavy parts easily. These are called ro-ro ships because parts are rolled on and off using wheeled platforms. One such ship is the City of Hamburg, measuring 126 meters long and 20 meters wide, with 5 times more cargo space than the Beluga XL. From Hamburg port, Airbus's massive aircraft sections are rolled directly into the ship using moving platforms. No cranes needed. This ship then travels 1,600 kilometers from Hamburg to the French port of Saint-Nazaire. But this journey isn't easy. The North Sea is notorious for storms and waves reaching up to 5 meters high. Just imagine, if a 400-crore wing gets even a scratch during transport, the entire wing must be rebuilt. To prevent this, the ship's crew checks the cargo chains every 4 hours, and 24/7 surveillance cameras monitor the cargo for any signs of risk. Once at the Saint-Nazaire port, there's a brief stopover. Then, the parts are offloaded and loaded again onto specially designed barges, which carry them up the Garonne River to the city of Bordeaux. And here comes the biggest challenge, the Pont de Pierre Bridge. This historic bridge, built in 1810, has arches that are not all the same size. Only arch number 9 is wide enough, at 19 meters, to allow the barge to pass through, with only inches of space on either side. But the real issue is the height clearance. That depends entirely on the water level, which is influenced by tides from the Atlantic Ocean, even though the bridge is 60 kilometers inland. Under normal conditions, the water level is too high for the barges to pass under the arches. But every 12 hours, the captain has just a 3-minute window of opportunity when the tide drops low enough. If that window is missed, the entire convoy must wait 12 hours, which delays Airbus's entire assembly schedule. To solve this, Airbus designed adjustable platforms on the barges so they could pass under the bridge safely during low tide. This might seem like a small part of logistics, but its importance is enormous. So far, we've covered the sea and river journey. Now let's talk about the final leg, the journey by land. From Bordeaux, Toulouse is still 250 kilometers away. This journey begins with a 50-meter-long super truck. Each of these trucks is powered by a 650 horsepower engine and has 96 wheels. These super trucks carry Airbus parts to the final assembly unit in Toulouse, but not without challenges. To minimize traffic disruptions, the convoy moves only at night. Roads and highways are shut down temporarily during the transit. A team of 40 people, including police, escort cars, and engineers, travels with the convoy. The most challenging part? Navigating through narrow roundabouts and sharp turns in small towns. Sometimes, a 15-meter-long wing hangs off the back of the truck, just centimeters away from lampposts, trees, and rooftops. Finally, when these parts reach the Toulouse assembly unit, they are pieced together within hours thanks to high-tech systems. To join the fuselage of the world's largest passenger aircraft, the A380, over 19,000 rivets are used. Another 4,000 rivets are used to attach the wings to the fuselage. Once engines, electronics, interiors, and paint are added, the aircraft is ready for delivery. It takes about 9 months to fully complete an A380, from manufacturing its parts, transporting them, and finally assembling them. To date, only 251 units of the Airbus A380 have been built, because not every airline is capable of operating such a massive aircraft. Surprisingly, 50% of all A380s belong to a single airline, Emirates. This aircraft can carry up to 850 passengers in one flight. Its takeoff weight is about 575,000 kilograms, equal to the combined weight of 300 SUVs. Its cost? A whopping $445 million US, or around 3,800 Indian rupees crore. For the same price,